Here is my 5th DER and 2nd ISP of my grade 12 year. Project 3.20.5, Medium ISP, Duckman Delightful Docket. The Duckman Delightful Docket, or DDD for short, is a basic circuit banked off of an idea that hit me earlier this year when my family received a card that played music. With one major flaw, that being, you needed to press a button to hear the noise. Within the DDD, there were three main aspects: hardware, design, and manufacturing, involving a variety of new skills such as mass prototyping, ribbon cable uploading, and manufacturing communication overseas, all of which are incredibly applicable skills necessary not only within my future as an aspiring engineer, but also my future as a problem solver and go-getter. Within the first aspect of this project, the hardware was a reasonably simplistic circuit, yet an extensive criterion was to be met, being a cheap and effective circuit, adding a level of complexity to such domain. What I mean by that specifically is when designing a product with the goal of mass production, the cost is a massive factor, something that I will get into later, but for now, the necessity for the bare minimum was in mind. The circuit was composed of a piezoelectric buzzer, an AT-Tiny85 1680 ohm fixed resistor, two 3-volt lithium cell batteries, CR1220, one 6-pin ZIF connector, and the ACES AVR ISP PCB. A basic MCU, the AT-Tiny85, was manipulated to control the piezoelectric buzzer within the DDD circuit by waiting for a low on its PB3 input. In addition to a custom DDD sensor within the PB3, a pull-up resistor is present, preventing any unwanted noise. Once a low is detected, a sound of the user's choice is then played through PB2 within the AT-Tiny85. The onboard coding was the final portion of the DDD circuit, and arguably most difficult. The last component was the 6-pin ZIF connector, which was wired to the AT-Tiny85, and with the addition of the ACES AVR ISP PCB, the 6-pin ZIF connector was used to upload code with the AVR Pocket Programmer. The second portion of the Duckman Delightful Docket was the design, involving two PCBs, one THT and the other SMT, and a custom card designed with Adobe Illustrator. Firstly, both PCBs were designed with an Eagle, being extremely compact, under 4 by 2.5 centimeters, and the THT version measuring 0.6 centimeters in height versus the SMT's 0.4. Populating both PCBs not included within the circuit are the THT lithium coin cell holders, added for additional security. The second design portion was the custom RCC X ACES Collab acceptance card. Designing the card was no accessible feat, involving multiple drafts, but concluding on the modern, minimalistic design featuring RCC's signature royal blue. The third, final, and most obscure portion of this project was the manufacturing of the DDD. Within this portion of the project, I had the goal to create such a product for under $3 Canadian a card, excluding labor and paper, as these were two things that had many different levels, and concluded with a price of $2.49 each card. To accomplish this task, two major things were done. The first being the opportunity to contact a variety of factories overseas to discuss optimal prices regarding parts, and the second being the panelization of PCBs, drastically reducing the cost on that end. Ultimately, I cannot be happier with this opportunity to create such a project, teaching me various new skills and broadening my knowledge within the engineering world, and cannot be more looking forward to my future projects.